Welcome to my lecture series. Today we discuss about photonics and fiber optics. So in that photonics is an area of study that involves the use of radiant energy whose fundamental element in photon. So the term photonics thereby empathized that photons are neither particles nor waves, and they have both particle and wave nature. It deals with generation, emission, transmission, modulation, signal processing, switching, amplification, detection, and sensing of light. And the applications of photonics are virtually unlimited. Some of photonics applications are given consumer equipment, that means barcode scanner, printer, CD, DVD, remote control device, and telecommunications, optical fiber communications, medicines, corrections of poor eyesight, and laser surgery, surgical endoscope, tumor removal. So there's a lot of applications are there. The photonics field began with the invention of laser and optical fibers. So the devices that run off light have a number of advantages over those that use electricity. So light travels about 10 times the speed of electricity. Does that means that data transmitted photonically can travel long distance, a fraction of time. So the unit describes the principles of laser actions, types of laser, applications of laser, and fiber optics. And next we discussed basic of laser. So laser sunshine is the light amplification by stimulated emission of radiation, and the property is so laser has a four unique characteristics that make it different than ordinary light. So they are highly monochromatic, highly intense, highly directional, and high coherent. So, so the monochromatic means that it contains of one single color or wavelength. So even though some lasers can generate more than one wavelength, it is extremely pure and consists of a very narrow spectral range. And high directional, that means beam is well collimated, that means very parallel. So and travels over long distance with a very little spread. And ordinary light spreads in all directions. Its angular divergence 1 millimeter per meter, so 1 meter per meter, but the angular divergence of laser is 1 millimeter per meter. So hence the laser light can be focused to a very long distance without divergence. That means a coherent, the wavelengths of laser light are phase in space and time, whereas ordinary light can be mixture of many wavelengths, so which are not in phase. It possible to observe interference of effects from the two independent laser beams. So the coherence of laser produces a high power, that means 1.5 into 10 power 12 watt per centimeter square. And a high intense beam is ordinary light spreads in all directions. Already we know that the intensity is less. So whereas the intensity of the laser beam is very high due to high directionality. So further, the emission of photons in ordinary light is 10 power 8 photons per second. So whereas the emission of photons in the laser 10 power 18 photons per second, and hence the laser has a high intensity. And next one, conditions for laser action. So first one, population inversion. That population inversion, denser medium is greater than to rarer medium in the atoms of medium. So the energy density of radiation of the medium should be increased, and the ratio of Einstein coefficient should be less. so that the more stimulated emission to take place than the spontaneous emission. Thank you. We discuss in next video.